We are running.
We're going to talk about water conductivity for this session. Water conductivity is a very important environmental factor that affects the efficiency of electrofishing. Fortunately, we know how to adjust for changes in water conductivity using the power transfer model, which in turn are used to build the standardization tables, the volt or amp output goal tables that we use in the field. So the idea is you go to the sampling site, you take a water conductivity reading, you go to the table, you find the conductivity, and then you look over to see what are the target volts or target amps that you should be setting for that particular site as a guide for successful electrofishing. Now, water conductivity is a little tricky because actually there are two types of water conductivity. One is specific, which most of us have heard of, and the other is ambient. Specific is based on removing temperature from the equation. So water conductivity is a result of ions in the water, the ion concentration, and temperature. So warmer water has higher conductivity than cooler water. But specific conductivity is after the ionic concentration, so it doesn't want temperature to play a role. So what we see with specific conductivity is that the conductivity will be referenced to some water temperature. So what the conductivity would be at some water temperature. Typically it's 25 degrees C. So we'll see specific conductivity of 100 and the specific temperature is 25 degrees C. The other conductivity type, that is what is important for electrofishing, what is important for these output goal tables or these standardization tables, is ambient conductivity. And ambient conductivity takes into account temperature. So if you're at a sampling site, you want to know what the conductivity is, which is a factor of the ions in the water and the temperature. You don't care if what the conductivity is at 25 degrees if you're electrofishing at 15 degrees. You want to know what the actual conductivity is, and that's called ambient. And that's where the confusion lies, because biologists will take specific conductivity and try to apply to the tables when they should be taking ambient conductivity. So we're going to have a little demonstration to try to look at the differences between specific and ambient. So I'm going to use a commercially available meter. It's called an X-Tech EC100. And this meter, there's a lot of meters, inexpensive meters that are accurate in the out there. And I've checked this one against expensive meters, conductivity meters, and it's very accurate, inexpensive. So this is one that we're going to go with. So basically, it's got an on-off button here, and an on-off button here. And if I press it, it should turn on, hopefully. There it is, and it'll cycle through, and it gives the conductivity reading in microsiemens per centimeter. It just says microsiemens, but it's the valid unit is microsiemens per centimeter. And then the lower number is the water temperature. So it has a cap on the bottom here that protects the electrodes, so you have to take that off in order to make a sample. You can see the electrodes in there. So coming back, and we'll do the same thing with this other one. and turn it on. Just a punch of the button, it cycles through again. Hopefully we'll get to the readout screen. There it is. And we'll take off the cap. And so what we'll do is we'll go ahead. I've labeled one of them on the top, labeled number 1, and the other one just nothing. So it's just the other conductivity meters, just to keep track. So anyway, we'll put them in. And let's see here. Let's see what kind of readings we have. There we go. Let me get there. Okay, so on the bottom, we see that the temperatures are reading pretty close to each other, the water temperatures, but the conductivity readings are quite a bit different. So in this one, we have a conductivity reading of 522. In this one, we have a conductivity reading of about 707 microsiemens per centimeter. So quite a discrepancy. That's a big difference, maybe almost 50%, 40% different. So why is, what's the issue behind, causing this? What are the factors causing this difference? So let's take a look at the meters themselves. And you go out and you take conductivity because you can. Because it's easy to turn it on, it's easy to stick the meter in the water. But sometimes you have to kind of stand back, and I'm terrible at this too, but I would get out the instruction manual and see how these meters are configured, how to work them properly. So in this case, I'm going to go to this meter, and I'm going to go to the background settings and see what it is, what's going on behind the scenes. So I'll press that down, and I get this screen that is just the beginning screen. I'm going to press the button here, and I get another screen that's got a blinking C. That's just to change the units from centigrade to Fahrenheit for water temperature. So I'll just click on it. There it goes, Fahrenheit. Click back. There's centigrade. Go to the next screen. Now I get this 25 degrees C. What is that? Well, let's just kind of fiddle around with it. I'm going to hit this button anyway, and there it goes, 20 degrees. Oh, so I have two choices, 25 degrees or 20 degrees. This is the specific temperature that you can set. So in this case, if you were taking specific conductivity, it would be referenced to 25 degrees. I could reference it to 20 degrees if I wanted to, but typically, more commonly, 25 degrees. So that's what that is. So this is set up for a specific conductivity to 25 degrees. I'm going to look at the next one, and it's got 0.0 C. What is this? Well, that is the percent change that the unit makes for every degree difference that there is between water temperature and the specific temperature that you set. So how these machines work is that when you take a water conductivity reading, think of it this way, it takes a reading, but it doesn't display it, and then it takes a temperature reading, and it calculates the difference between the water temperature and the specific temperature you set. In this case here is 25 degrees, and adjusts the original conductivity reading by that percent per degree difference. So in this case, this was saying, do not adjust. The temperature, make no changes to your original reading, despite the differences in water temperature and specific temperature. So what you see displayed is the actual conductivity not adjusted to some reference temperature. So that would be ambient conductivity. So let's look at the other one here. Let's do the same thing with that. We're going to zoom in. There we go. And I'm going to hit this top button. Oop, I turned it off. Let me turn it back on again. Wrong-o. All right, I'm going to press it and hold it. And that's going to take me to the setup screen. So the next one, again, is, there we go, the unit change from centigrade to Fahrenheit. The next one is what specific temperature you're using. Again, 25 degrees. And then the next slide is 2.0, different from this other conductivity meter, which was 0.0. This is 2.0. So what this does is it takes an initial conductivity reading, it measures the water conductivity, the water temperature, and says what's the difference between the actual water temperature and the specific temperature you set, and for every degree difference, adjust the reading by 2%. So this is a specific conductivity meter. It's reading specific conductivity. So now, wonder if I take this adjustment factor and take it down to 0. Whoop, going the wrong way, 2.1. I'm just going to take it down to 0. Whoop, yeah, went to the other way. How you like that? Didn't realize I'd do that. Okay, 0.0. So that's the adjustment factor. So both of these conductivity meters are now set at no adjustment factor. So they both will be giving me the raw conductivity reading, that is the ambient conductivity reading, unadjusted for temperature. So let's get this one, and let me get this one set up here the same way. Let's see. Get it back here. There we go. Finally. Okay, so they're both now, not quite both. Get this other one same way. There we go. Now we got them both the same. So since there's no adjustment for temperature, they should read the same. We'll see if they do. All right. Let me get them evened up here so we can see them. All right, there we go. Let's see how that works. There we go, maybe, yeah, there we go. Okay, so now we're reading very close, 527, 520, about the same temperature. So they're both now reading similarly. They are reading ambient conductivity, which is the type of conductivity we need for electrofishing, and that's the conductivity we go to the tables with, and that's what those tables are built on, ambient conductivity. So with that, that wraps this up.